Alright, so the last one. How far does the runner's velocity time graph as shown in this travel in 12 seconds? And what gets randomized here is what time period they ask you about. So I've seen some people get asked like 8, and some people ask 12, and some people ask 16. And so really this is pretty easy to solve. We're going from velocity time. So we're going from velocity time to position, or what we really want is displacement. We're asked how far does the runner travel. So what we're asking for is displacement, is what we want to find, just delta x. So what's pretty easy here is to do this. And if you remember Dr. Osborne's ladder of death, here's acceleration versus time, here's velocity versus time, and here's position versus time. And if you want to go up the ladder, you take the slope. And if you want to go down the ladder, as we're doing here, you take the area. So we're going to take the area under this velocity versus time curve. Well, in my case, this is pretty easy. You can do trapezoid rule for all these things. You could like calculate the area of this triangle and then this rectangle and then do like a trapezoid rule here. That's all legit, and I encourage you to do that if you're comfortable with it. In this case, though, it's almost really easier to count squares. So if we take one square here, let's take, for example, this square here. I have one square. I'm going to draw a little close-up of one square, and say each square on that grid is has a height of 2 meters per second. So you can see over here you're going from 0, 2, 4, 6, 8, okay? And then each one has a width of 2 seconds. And so you can compute your total area there as 4 meters. This is the area of this square right here. So what you can do is actually you can just count the number of squares and then figure out, and multiply that by 4 to find your total distance traveled in meters. So over here we have if you look at like this little bit here and this bit here, you can sort of see how they'll fit together to form one whole square. And then if you look at this little wedge up here, you can see how you can put that down in there and form another whole square. So really what you have is 2 squares in a 0 to 2 second region. And you can kind of see that's the average, like your average velocity, through that point would be 4 meters per second. Okay, so there's 2 squares. And then here we have 4 squares wide here and 4 squares down here. So we have a total of 16 squares. So up through 10 seconds, we have 18 squares. Okay, here's a 19th square. Here's a 20th square. And then you can see this and this, this little wedge here you can push down there. So that would be 21 squares. So just to check again, 2 squares over here, 16, total of 18 squares, 19, 20, and then this together is 21. So we take, just to be sort of super duper safe, if we take 21 squares times 4 meters per square equals 84 meters. So let's plug this in and see if we have it right. 84 meters. Boom, 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 boom. And, oh yes, how about that? All right.